I know someone with lupus.
My girlfriend.
My mommy.
We work together.
My sister.
My neighbor.
I know someone with lupus. She's so tired.
Fatigue, achy joints, and fever.
Severe chest pains, heart
Her
problems.
kidneys gave up.
He had a seizure.
Pain never stops.
Now she's on dialysis.
Someone you know.
Someone you know.
Someone you know.
Someone you know has lupus.
But there is hope. For information, contact the Lupus Foundation of America.
My name is Bruce Richardson. I'm currently Chief of Rheumatology at the Ann Arbor Veterans Affairs Hospital and affiliated with the University of Michigan. I'm a basic researcher investigating mechanisms which cause human lupus. What our current interest is with the Lupus Foundation is to look at why men get lupus. The reason we're asking the question is that 90% of lupus patients are women. There's been work performed over the last several decades which shows that estrogen is important in predisposing women to develop lupus. More recently, reports have started to appear that having two X chromosomes also will predispose you to lupus. Throughout this time, it's been neglected why men should get lupus at all when estrogen and having two X chromosomes is important. Not address why men develop lupus. However, when men get lupus, it tends to be more severe and can be more difficult to treat. One of the more recent breakthroughs in lupus is that the environment can affect people through what's called epigenetic mechanisms. Let me explain to you what epigenetics is. It's a bit of a difficult concept, but it underlies many of the cellular processes in your body. It's known that every cell in your body has 9 to 10 feet of DNA. However, cells are so small that they have to be seen under a microscope, and those 9 to 10 feet of DNA are confined within the nucleus of the cell, even a smaller structure. In order to get the DNA packaged into the cell, it is super coiled. It's coiled many times upon itself, much like a slinky, so that it can all fit in the cell. This creates a problem for the cell, that packaging is so tight that it's difficult to get other molecules in there so that you can synthesize the RNA and expression to occur. So for any gene which the cell needs to express, that region of the DNA needs to be opened up. That coiled structure needs to be separated somewhat so that the proteins can get in and molecules can be expressed. Genes that a cell does not need are left tightly packaged because they could be inappropriately expressed at the wrong time or the wrong place. And every time a cell divides, these marks on the DNA, which signify where the DNA is to be opened up, have to be replicated. So every time a cell divides, genes which the cell doesn't need to be maintained in a tightly packaged configuration, while those genes which the cell is going to express needs to be opened up. The molecules which mediate that, there's marks on the DNA, it's called DNA methylation. The regions to remain silenced are methylated. The regions which are to be opened up are unmethylated, and these serve as signals. However, those methyl groups come from what you eat. And every time the cell divides, if you haven't been eating well, for example, the marks will not be put on and you'll get inappropriate gene expression. And there are other factors involved also, but this is a very environmentally sensitive portion. And current evidence suggests that problems with these epigenetic mechanisms leads to leakiness and expression of the wrong genes in the lymphocytes from patients with lupus. There's many things which could potentially affect the chromatin. Some drugs that people take, like procainamide or hydralazine, are known to cause lupus in some people. It turns out that both of those drugs inhibit this process. Procainamide inhibits the enzyme that puts the methyl groups down, while hydralazine prevents turning on the gene for that enzyme, which puts the methyl groups down onto the DNA. Now, ultraviolet light will also prevent the methylation of DNA. It's possible that many other things in the environment which work like hydralazine or procainamide could be inhibiting the enzyme. As people age, the levels of that enzyme decrease, so the chromatin structure gets leakier and could possibly play a role in the development of lupus as well. Our hypothesis was that men having normal estrogen levels in one X chromosome would have to have one of two, or maybe both, problems going on at their DNA level. It's known that genes predispose to lupus, and it's possible that men that develop lupus have more of those genes than men that don't. Now, the other possibility is that this process of epigenetic mechanism of DNA methylation is known to be related to disease activity. As lupus flares, DNA seems to demethylate. It can also be shown that if you experimentally demethylate cells and put them back into an animal, the animal gets lupus, so we think that demethylation causes it. This would suggest that one other potential mechanism why men would get lupus more when they lack other predisposing things is they have a greater degree of DNA demethylation. So that the two parameters or variables that we're looking at in this study are the total number of genes which a given man with lupus has that might predispose him to developing lupus, and how that relates to how extensive the DNA demethylation is in his lymphocytes. Our hypothesis is that they require either more lupus predisposing genes or a greater degree of DNA demethylation, or both, to develop lupus compared to a woman with a similar activity in her lupus. At the moment, we don't know how to fix genes that people have. We can interfere and improve DNA methylation. Since the degree of DNA demethylation is strongly related to the severity of a lupus flare, we actually think that the severity of a lupus flare will be proportional to the degree of demethylation as well as the number of predisposing genes that the man has. What we would like to do in this study is compare men and women with lupus flares of similar intensity. we think that the men will have greater DNA demethylation than women at that, with that degree of flare, as measured by an index called the Systemic Lupus Erythematosus Disease Activity Index, or SLEDI. If we confirm our hypothesis, we will find that the men do have more DNA demethylation compared to women with similar disease activity. This will do two things. It will suggest why men get lupus, but it will also confirm the hypothesis that the DNA demethylation is causing the disease and is directly related and likely responsible for the disease flare. The implication of the research is that preventing the demethylation of the DNA will prevent lupus flares. And this may be as simple as adjusting the diet. More methyl donors, this is folic acid, methionine, choline, other nutrients could be important and may reduce lupus flares. The other aspect here that is known is that the enzyme which puts the methyl groups on the DNA, the levels are low in the cell. And a better understanding of how that enzyme is regulated and why it's decreased in lupus will suggest ways to prevent those decreases. Our preliminary data right now suggests that the decreases are caused by signaling problems within the cell, and in particular a signaling molecule called PKC delta, which doesn't work in lupus patients. Discovering why that molecule is inactive and that degree of inactivity is related to disease activity will suggest how we could prevent the decreases in that enzyme. It may not just be folic acid. There are many nutrients involved in the transmethylation reaction, which the enzyme catalyzes, but supplementing methionine, folic acid, betaine, choline, all could play a role. There is also evidence that homocysteine, which accumulates in the bloodstream of some patients, inhibits DNA methylation. And decreasing homocysteine levels may also be an approach to treating or preventing flares.
Space. Y'all need to understand what I'm saying. See, once I purified my house, people would come. Now watch this. This is gonna bless somebody. People come by. I just thought I'd drive by. I just hold the door. Now we're gonna stand on this porch and talk. You ain't coming to my house. You ain't dropping off no gossiping demons. You ain't dropping off no lying spirits. No. No. And the reason why is that you got to sanctify your atmosphere, because a woman, watch this, when a woman get ready to have birth, they got to put it in a place where everything in the room is sterilized. Because you get ready to bring forth something. Come on here, somebody. You ain't got time for no good folk to be sitting up in your house. People ain't got no consecration on them. People got lying spirits. No. You ain't coming in here. I'm going to sanctify my space, because when I get ready to be birthed, I'm not bringing nothing in here contaminated.
Blessed are the poor in spirit, for theirs is the kingdom of heaven. Blessed are those who mourn, for they shall be comforted. Blessed are the meek, for they shall inherit the earth. Blessed are those who hunger and thirst for what is right, for they shall be filled. Blessed are the merciful, for they shall obtain mercy. Blessed are the pure in heart, for they shall see God. Blessed are the peacemakers, for they shall be called sons of God. Blessed are those who are persecuted in the cause of right, for theirs is the kingdom of heaven. Blessed are you when people abuse you and persecute you and speak all kinds of calumny against you for my sake. Rejoice and be glad, for your reward will be great in heaven, as it was for the prophets persecuted before you. In your prayers, remember your Father knows what your needs are before you ask him. This is how you should pray. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come. Thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our debts as we forgive our debtors. And lead us not into temptation, but deliver us from evil.